Welcome back. Today we're going to look at section 8.2, which is on sum and difference identities. So you have some more formulas that you will need to memorize for the test. We've broken this up into first we'll do the sum and difference formulas for sine and cosine. They're very similar to one another. And then we will look at the ones for tangent. Okay, and you only have these for the first three trig functions. You won't have to worry about these for the inverse, the cosecant, secant, and cotangent, okay? All right, so here are the formulas for sum and difference. The thing with these is you have to use these formulas when you're finding the sine or cosine of two angles either added together or subtracted. So you can't just do the distributive properties. There's no such thing as distributing a word through numbers, okay? So that's not a distributive property. You have to use the formula in order to do this. And the whole point of this is that we're going to be finding exact values. So these numbers either need to come off of the unit circle, or you might need to draw triangles and find the values based on a right triangle using your trig ratios. All right, so for sine, okay, I want you just to notice that when you do the formula, you're doing a sine of one angle and a cosine of the other. Notice the words are different. Okay, so you always start with the first angle. That's always the first thing in every problem. So for sine, you're going to use different trig functions with the two different angles, but the sign in the middle will be the same sign as what you see in the problem. For cosine, notice the words are the same. Cosine, cosine, sine, sine. But the sign in the middle is different, okay? So the way I learned this was I either said, well, either the words are the same together or you use the same sign in the middle, but you never do both. So the way that I remembered which one was which is I know that sine, the word S-I-G-N, so for the sine function, it'll have the same sign, which means it'll have different words. So that meant for cosine, we would have the same words, but a different sign. So that's just how I taught myself to learn this, but any way you guys have is great. Okay. All right, so let's look at a couple of these problems so we can see how this works. So we're going to start off kind of simply with just using numbers that we already know in the unit circle. Okay. So find the exact value of each using the sum and difference formula. So again, I can't just do the sine of 120 plus the sine of 135. That doesn't work, okay? That's a word. Words are not part of math, so that's not a distributive property. So we would have to set up the formula to do this. So remember, sine means the same sign, so we're going to use different words. And you always start with this at the beginning. So we're always going to start with the sine of 120 degrees, and then we do the cosine of 135. So different words. But then we would do a plus sign in the middle, same sign, and then we'll switch the words. So then we'll do the cosine of 120, and then the sine of 135. Okay, so again, it's helpful to know your numbers on the unit circle so that you get these correct, and you don't have to think too long about it. So go to your unit circle if you need to remember what the sine of 120 degrees is, which is the square root of 3 over 2. And then the cosine of 135 is negative square root of 2 over 2. Plus, then we're going to do the cosine of 120, which is negative 1/2. And then the sine of 135, which is the square root of 2 over 2. So again, these numbers are coming off of the unit circle, so make sure you know those. All right, and then we're just going to simplify. So square root of 3 times negative square root of 2, that's negative square root of 6. 2 times 2 in the bottom is 4. Okay, and then plus negative 1 times the square root of 2 is a negative square root of 2, and the same in the bottom is 4. So I can add my numerator since I have a common denominator, and I'll just make that a minus sign in the middle. So we end up with the square root of negative square root of 6 minus square root of 2 over 4. That's an exact answer. Okay. Now you could put this in your calculator just like that and you would get a decimal answer, but that's not exact. So when you are asked for exact values, again, you're using numbers off of the unit circle. All right, so now let's look at a radian problem. So, you're doing the cosines and sines. So whether you have a radian or degree problem, you're still going to get the same kind of answers because these numbers are the same no matter what you're doing. You just need to remember, you're working in radians, so where are those on the unit circle? All right, so this is a cosine problem. So same word, okay, different sign in the middle. So we always start with what we're given, the first thing. So we would do the cosine of pi over 6, cosine of pi over 4. By the way, you always use these angles. The sine just has to do with what sign you're putting in the middle. You never make that a negative angle right there, okay? All right, so we're going to use different signs, so that would be plus, and then we would do the sine of each. So sine of pi over 6 times the sine of pi over 4. Okay, now we just need to go to the unit circle and get these values. So the cosine of pi over 6, remember, is the square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2. The sine of pi over 6 is 1/2. And the sine of pi over 4, square root of 2 over 2. So you're going to notice that all of these answers are going to look very similar. The difference will be the plus, which one's positive, which one's negative. Remember, there's only so many numbers on the unit circle, so most of your answers are going to be very, very similar, okay? So once you get the hang of the formula, the whole thing is you got to get your signs right. You got to know what quadrant you're in. You got to know what the signs are, so just be careful with that. All right, so you'll notice on this one, we end up with the square root of 6 over 4 plus the square root of 2 over 4. So this one ends up square root of 6 plus the square root of 2. So very similar to the one we just did above it, even though it was two totally different numbers. Okay, and again, go back to your unit circle. We only have so many numbers to pull out from cosine and sine. Okay? All right, now, the whole point of this, typically you're not going to get a problem like this because those numbers are already there. The whole point of this is you're going to be asked to find the sine or cosine of a value that's not on the unit circle. So you have to figure out how to rewrite those numbers using multiples of 30 and 45 because those numbers are on the unit circle. Okay? So think about, the fact that we only have multiples of 30 degrees on your unit circle and 45 degrees. Then to do an exact value problem, we need to use those values. So for example, if you're asked to find, let's say, the cosine of 15 degrees, which is not on the unit circle, I could change 15 degrees to either 45 minus 30 or 60 minus 45, both of which equals 15 degrees. And then I could use the sum and difference formulas because I do know these values. Okay, so that's the whole point of what's coming up. So quickly, we're just going to do a couple of examples to show you that. So and there's lots of combinations, just like you see here. There's more than one answer. I'm just going to put one, but you can come up with, as long as it works and as long as the numbers are on the unit circle, that will be fine. Okay, all of these work the same. So 75 degrees. The easiest one I could figure out for that, I would do 45 degrees plus 30. Those would be on the unit circle, and that equals 75. All right, if you have a negative angle, what I would do is put the smaller number first. Okay, so make it a subtraction problem. So negative 105, I could do 45 degrees minus 150 degrees. Now that would equal negative 105, and both of these numbers are on the unit circle, so I could use a formula. All right, 5 pi over 12. For a lot of you, we don't know what that is, so change that to a degree just so you can think about it. So 5 pi over 12, if I go from that to a degrees, remember you do 5 divided by 12 and then times 180, and that would give you 75 degrees. So this is actually the same as that. So I'm not going to use the same two values. Let's use something different. So let's say for 75 degrees, I will do 120 minus 45. That's 75. Now, problem is they gave me this in radians, so I have to give my answers in radians. Okay? So remember, whatever you're given, you got to work in that form. So since I know 120 and 45 now, I can just change those to the radian form. Right? So 120 is 2 pi over 3, and 45 degrees is pi over 4. So that would be 75 degrees. So 120 minus 45, okay? So I have no problem, and that's what you probably will do, is change your problem to a degree so that you can work with it easier. And then once you get your numbers, change it back to the radians, okay? So I could have just used pi over 4 plus pi over 6. That would have been fine, okay? But again, I just wanted to show you there's more than one way to get 75 degrees, okay? All right, so now we're going to use this to kind of do what we did up here, but we're going to have to come up with those numbers ourselves, okay? All right, so look on the next page. Use adding or subtracting. So we're going to use our sum and difference formulas to find an exact value. So again, you could put this in your calculator, but that's not going to be an exact value. You're going to get a decimal. So we need to figure out the exact value by using two numbers that are on the unit circle. So let's say I break up the sine of 15 degrees into 45 minus 30. Okay, 45 minus 30 is 15 degrees. And now I can use my sum and difference formula to find this exact value. So I would do the sine of 45. Remember, when you're doing sine, it's the same sign in the middle, different words. So then I would do the cosine of 30. Same sign in the middle, so minus. And then the cosine of 45, we're going to switch them up, and then the sine of 30. Okay, so again, they're going to be very similar as we go. All right, so sine of 45, square root of 2 over 2. The cosine of 30 is the square root of 3 over 2 minus cosine of 45 times the sine of 30. It's 1/2, right? Multiply that out, we get the square root of 6. I'm just going to put it all over 4 now because we're kind of getting the hang of that. And then this will be square root of 2, so minus. So again, you go back and look at your answers. All that's changing a little bit are those plus and minus and where the square root of 2 and where the square root of 6 might end up. All right, next one is 7 pi over 12. Okay, so we know 7 pi over 12. Again, do you know where that is, what that is in degrees? So I'm going to do 7 divided by 12 and then multiply that by 180. So that ends up being 105 degrees. So I'll just write that there. So figure out how to get 105. So 105, I might use 45 plus 60, let's say. That's 105. So I would just want to write this out in radians. So I would do the sine of 45, which is pi over 4, plus 60 degrees, which is pi over 3. Okay. So that would equal what I needed. So you see, I worked with the degrees to help me figure out how to break this up, because even I can't really tell you that without trying to figure that out. So go through degrees, but make sure your problem is using the same numbers that the problem's giving you. So if you're starting with radians, we need to go with radians. Now remember, even though we're doing the radians, we're still getting these kinds of numbers, right? We're still getting the cosine and sine values, so that's not going to change. All right, so this is sine with a plus in the middle, so different words. So sine pi over 4, cosine pi over 3. Same sign in the middle, so plus. And then change your words, cosine pi over 4, sine of pi over 3. Okay? Fill those in, sine of pi over 4, square root of 2 over 2. The cosine of pi over 3 is 1/2. Cosine of pi over 4, square root of 2 over 2, and the sine of pi over 3 is the square root of 3 over 2. All right, so I know this is going to be over 4, and now this time I get the square root of 2 up front and a positive square root of 6. Okay, so exact values, exact values. All right, last one, 17 pi over 12. Again, if you don't have any idea what that is, change it to a degree. So 17 divided by 12 times 180, that gives you 255. So figure out how you're going to get 255 using two numbers that are on the unit circle. Let's say 210 and 45. Okay, and again, there's lots of possibilities. Just make sure these two numbers are on the unit circle. All right, so 210, remember we're going to change these to radians. So let's do the cosine, and 210 on your unit circle is 7 pi over 6. That's That's what it is as a radian, plus, and then 45 degrees is pi over 4. So that's exactly 210 plus 45, which are on the unit circle. All right, now we're doing a cosine formula, so same words, different sign. So cosine 7 pi over 6, cosine pi over 4. Okay, so same words, different sign, so minus, and then sine 7 pi over 6, sine of pi over 4. All right, so now we just need to get our values. So what is the cosine of 7 pi over 6? So go to your unit circle, or hopefully you know that's in the third quadrant. So cosine is negative, so that's negative square root of 3 over 2. Cosine of pi over 4, that's first quadrant, so everything's positive, minus the sine of 7 pi over 6. So again, you're in the third quadrant, so sine is also negative, so that's negative 1/2. Sine of pi over 4 is a positive square root of 2 over 2. So the signs are real important. I can't give you partial credit on these if your signs are wrong, okay? So you have to make sure you know your numbers and the signs. It's all kind of part of the same thing. All right, so this is going to give us over 4. So the first term will be negative square root of 6. And then here is a negative square root of 2, but you have minus a negative, so that's going to end up being plus. Okay? All right, so you look, we just did 6 problems, and you look at those answers and how similar they are. So when you're on the unit circle, again, not a whole lot of leeway on what kind of values you're going to get. Now, example 6 are not on the unit circle, so these will be a little bit different for our answers, but we're still going to do the same thing. All right, so first thing you always want to do is look at the problem and look at what you're trying to find. Find the exact value of the cosine of alpha minus beta. So before I even look at anything else in the problem, I'm going to do this formula, okay? So this is a sum and difference formula for cosine. So same word, different sign in the middle. So this will be the cosine of alpha, cosine of beta, plus the sine of alpha, sine of beta. Right? Same words, different sign in the middle. So remember what we've been doing. This is exactly like this. So we're going to need 4 values, right? 4 values for those. So this is kind of, I'm not even looking at my problem yet, what I have. So I need 4 fractions, 4 answers to go in here for these. So look at what they gave me already. They gave me the sine of alpha is negative 2/5, and we know that alpha is in quadrant 4. And then they gave me the tangent of beta, negative 12/5, and beta is in quadrant 2. And I gave you some quadrants or coordinate planes here so you could figure out your other values. So all I have out of these 4 right now is that the sine of alpha is negative 2/5. So I know that. That's all I know. So I have to do some work and figure out the rest of these, okay? So let's start with alpha. So here's going to be alpha stuff. Alpha is in quadrant 4. Okay, so remember, you always draw your triangle to the x-axis. So there's angle alpha right there. And you know the sine is 2/5, negative 2/5. So sine is opposite over hypotenuse, okay? So then we would do the Pythagorean Theorem to figure out this side. So c squared equals a squared plus b squared. So we would do 5 squared equals negative 2 squared plus b squared. You can use x, y, and z, doesn't really matter. We're just doing the Pythagorean Theorem, and I know this is the hypotenuse. So that would be 25, and then I'm going to get 4 over here, so I'm going to subtract 4. So b squared is 21, so b would be the square root of 21, right? So that's that side right there, the square root of 21. All right, so now I know that the cosine of alpha, in the 4th quadrant, cosine is positive, okay, which is the adjacent side over the hypotenuse. So that would be the square root of 21 over 5. That's the cosine of alpha for this angle. So now I know that is the square root of 21 over 5. So I'm just trying to, all I need is what I need for this problem. All right, now, beta is in quadrant 2. So here's quadrant 2. Here's beta, okay, angle beta. So they gave me the tangent of beta is negative 12 over 5. So that's opposite over adjacent. So opposite, negative 12 over adjacent is 5. Actually, this should be negative. We go left. That should be positive, right? So negative 5 left, up 12. All right. So there's my negative sign. All right. So I would need to figure out this number using the Pythagorean Theorem. So again, c squared equals a squared plus b squared. Again, z squared equals x squared plus y squared, however you want to do it. All right, so c is what we're looking for, the hypotenuse. So negative 5 squared plus 12 squared. So we end up with 25 plus 144, which is 169. So the hypotenuse would be the square root of 169 and 13. So now we can do the sine of beta and the cosine of beta. Now we have our information. All right, so the sine would be opposite over hypotenuse, and we're in the second quadrant, so sines are positive. So that's 12 over 13. And then we have the cosine of beta, which would be adjacent over hypotenuse, so negative 5/13. All right, so now we can fill in the rest of our sum and difference formula. So we need the cosine of beta here, which was negative 5/13. And then we have the sine of beta, 12/13. Okay? All right, so now we're going to just multiply. The square root of 21 times negative 5 is negative 5 square root of 21. And then 5 times 13, that would give you 65. Plus negative 2 times 12 is negative 24 over 65. So again, now we can simplify. You're always going to get a common denominator there, so that's nice. So negative 5 square root of 21 minus 24 over 65. Okay, so these answers are going to start looking much different than the other ones because these numbers are not on the unit circle. Okay, so but we've already gone through, so it's not new, nothing is new here. We still know how to find these. We've already done those. It's just you got to plug them into the right formula. Okay? All right. Next, we're going to look at the formulas for tangent. So tangents are a little different. So again, formulas you got to know. So this is the sum and difference formula for adding two angles together for tangent and subtracting. All right, so unlike sine and cosine where, it was all on one line, we've got a fraction here. So not too hard to remember. So tangent u plus tangent v, so again, same sign will be in the top, different sign in the bottom. And then in the bottom, you're doing 1 minus the product. You're going to multiply the tangent of u times the tangent of v. So for minus, the signs change. That's the only difference, is where the signs go. All right, so tangent of 75. So let's write that as the tangent of 45 plus 30. Okay, that equals 75. So we'll be doing this formula. Okay. Again, put that in your calculator. You're going to get a decimal, so we need an exact value. So we would do the tangent of 45 plus the tangent of 30 over 1 minus tangent of 45 times the tangent of 30. Okay? Then we would go to the unit circle and we would get those values. So the tangent of 45, that's the easy one, which is 1, plus the tangent of 30 degrees. Remember, tangent is y over x. So that's 1 over the square root of 3. So if we simplify it, we get the square root of 3 over 3. And then 1 minus, and then we're going to multiply these numbers together. 1 times square root of 3 over 3. Okay? So simplifying that, get a common denominator up here. We're going to multiply by 3. So that's 3 plus square root of 3 over 3 over. And then here we got the same thing except with some minus sign, right? 1 times this is just the square root of 3 over 3. Oops, sorry. Okay, so multiplying the top and the bottom by 3. Sorry, I wasn't on screen there. So here I just multiplied the top and the bottom of that by 3 over 3. Okay, get a common denominator. And again, the same thing here, but there's a minus sign. So this will be 3 minus square root of 3 over 3. Then when you divide, you're going to flip and multiply. So we got 3 plus the square root of 3 over 3 times 3 over 3 minus square root of 3. 3's are going to cancel, and we're left with 3 plus the square root of 3 over 3 minus the square root of 3. Okay? And I'm fine with you leaving the answer like that. That's perfectly okay. So there's your answer. Now in example 8, this one's kind of easier because you're going to go backwards. I'm going to slide this up just a bit so I can see the formula. So look at the formula. The minus signs in the top and the plus. So they're giving you this side of the problem. So we're going to take it back to this side. Okay? So since there's a minus in the top and a plus in the bottom, it's this one. So we're going to take the two angles, u and v, and write it this way. So that would equal the tangent of u, which is 7 pi over 9, minus v, which is pi over 9. So notice what happens here. We end up with the tangent of something we can do. 7 pi over 9 minus pi over 9 is 6 pi over 9, which happens to be the tangent of 2 pi over 3, which is on the unit circle. So the tangent of 2 pi over 3, remember, is y over x. So the square root of 3 over negative 1, which is just negative square root of 3. Run out of room there. Okay. All right. So sometimes going back to the left side gives you a number on the unit circle. So these were not on the unit circle. So typically when they give you the worked out side and the numbers are not on the unit circle, that's telling you to go backwards, and probably what you end up with is on the unit circle. Okay? All right. Now we're going to look at some verifying proofs. So remember, when you verify a proof, you can only work on one side of the problem. So we're going to look at the left side. This is a sum and difference formula. Okay? You can't distribute. So we're just going to work this out and hopefully end up with the sine of theta. So this is back to the cosine. So same word, different sign in the middle. So cosine pi over 2 cosine of theta plus the sine of pi over 2 sine of theta. All right, so these numbers, pi over 2, are on the unit circle. So what is the cosine of pi over 2? Remember, pi over 2 is up at 90 degrees. Cosine is 0. I don't know the cosine of theta, so that's just going to stay. The sine of pi over 2, that's the y value up there, which is 1. That's the sine of theta. Well, 0 times anything is 0. 1 times the sine of theta is the sine of theta. And 0 plus the sine of theta is the sine of theta. So that's what we were trying to prove, and we got it. All right, so same thing. Let's look at sine of x minus 3 pi over 2. That's the sum and difference formula for sine. Different words, same sign. So sine of x, cosine of 3 pi over 2, minus cosine of x, sine of 3 pi over 2. And again, 3 pi over 2 is on the unit circle, x is not, so you're going to leave those. So we're going to leave the sine of x and go find the cosine of 3 pi over 2. 3 pi over 2 is down at the bottom, that's 270 degrees, and the cosine of that is 0. Minus cosine of x. Right. The sine of 3 pi over 2 is the y value down there, which is negative 1. And sine x times 0 is 0. And then we have minus, and then negative 1 times the cosine is negative cosine. And a negative times a negative gives you that positive. And that's what we needed. Okay? So we proved it by getting the left side to equal the right. All right. All right, so this kind of goes back to what we just did with number 8. We're going to go backwards, okay? So let's look at a couple more that we can go backwards. So look at your formula, sine, cosine, different words. So when it's a different words, go back to the problem or your formulas on the very first page. Okay? When it's different words, then you're going to end up going back to this. And because we have a plus sign here, then I know it's going to be the plus sign here. So we're going to take this side and write it this way. So what were the two angles? So the two angles are 12 and 78. So this is going to be the sine of 12 plus 78. Okay? So that's how I know which one I went back to, because different words means the sine formula, and then you use the same one. Well, look, if you add those together, 78 plus 12 is 90. That is on the unit circle. So sine of 90, okay, remember that's up at the top, so that's 1. So by condensing this back to the left side, we got a number we could do, whereas these numbers aren't helping us any because they're not on the unit circle. So you can do it either way. Kind of weird how that works. All right, so example 12, we got cosine, cosine, so I know this is a cosine problem on the left, and then we would do the opposite sign. So we're going to do 7 pi over 12 minus 5 pi over 12. Go ahead and simplify that. 7 minus 5 is 2 pi over 12. And that is on the unit circle. We reduce that down to pi over 6. What is the cosine of pi over 6? Okay, that's square root of 3 over 2. That's an exact answer. All right, and then one more tangent. So the ones we just did. So this has got a plus sign in the top and a minus in the bottom. So that means we're going to take the two angles and add them. All right, so that's the tangent of 260 plus 40. So that gives us the tangent of 300. So that is on the unit circle, whereas these were not. So go to 300 degrees, that's in the fourth quadrant. Tangent is y over x, so that's negative square root of 3 over 1, which is negative square root of 3. Okay? All right, so that's going the other way. I kind of call that condensing, but you're going the other way. All right, last problem. Find the exact value using inverse trig functions. All right, so this one, numbers, that's not on the unit, well, that's on the unit circle, but this one is not. So let's do them both the same way. So the way I treat these is kind of look at our formula. So I'll just call this angle alpha, and I'll call this one angle beta, okay? All right, so remember the inverse trig function. If the inverse trig function of cosine is 1/2, then that means the cosine of alpha has to be 1/2. And if the inverse sine is 3/5, then if that's angle beta, that means the sine of beta would be 3/5. Okay, so we're going to do the same thing we did with that other one with the triangles, drawing these out. All right, so that means if we look at this, this is the sine. If we let that be alpha and the second one is beta, then this is a sum and difference formula. So the sine formula is sine alpha, cosine beta, different words, same sign in the middle, then the cosine alpha, sine of beta. So same exact formula, just we're going to have to find these numbers like we did earlier. Okay, so sine, cosine, right? Okay, so look at what we have. We have the cosine of alpha already is 1/2, so that can go there. And I know that the sine of beta is 3/5, that goes here. So all I have to do is find the missing two fractions that I need. All right, so cosine is 1/2, that's in the first quadrant. So here's alpha, and the cosine is adjacent over hypotenuse. All right, so adjacent over hypotenuse. Do the Pythagorean Theorem. So 2 squared equals 1 squared plus b squared. Okay. So 2 squared equals 1 squared plus b squared. So we get 4, 1. So we end up with b being the square root of 3. Right? 3 over there. So b is the square root of that. All right, so I now know I need the sine of alpha. So opposite over hypotenuse. So that's the square root of 3 over 2. And so that's why I said that one is on the unit circle, but we just use it the same way. All right, then let's do beta. That's a positive inverse, so that's also in the first quadrant. So beta, the sine is 3/5, opposite over hypotenuse. Okay, so if you do the Pythagorean Theorem, 5 squared equals 3 squared plus b squared, so we end up with 25 and 9. Subtract that over, we get 16, so the square root of 16 is 4. So now I know that the cosine of beta is 4/5, adjacent over hypotenuse. Okay. All right, so multiply this out, we get this 4 square root of 3 over 10 plus, and this would just be 3 over 10. So we get 4 square root of 3 plus 3 over 10. So there is that exact value. Okay? All right, so you can see when the numbers are on the unit circle, it's a lot easier. But doing these triangles, that's not new, and Pythagorean Theorem is easy. Again, you just have to remember your signs and be careful with that. Okay? All right, so you can get to work on this homework, and if you have any questions, please let me know. Okay?